All right, let's jump right into this explainer. Today, we're tearing into a recent Week 34 maintenance performance report from a manufacturing facility, and we're trying to figure out exactly why one of their most critical assets, line P, suffered a massive, completely unexpected efficiency drop. We're going to break down the hard data, hunt down the root causes, and walk through the exact recovery plan the engineering team scrambled to put together. If you're into a good data-driven mystery, you are definitely in the right place.
Take a look at this. It's what I like to call the illusion of safety. On the left side, the overall factory health, measured as mechanical efficiency, is sitting at a really solid 93.27%. That actually beats the facility's 92% target. So, from a distance, everything looks fantastic. But if you look just a bit closer, there's a hidden crisis. A severe, localized collapse is happening right under our noses, and it's being completely masked by the strong performance of other production lines.
And that localized collapse? It's happening on line P. In week 34, mechanical efficiency on this specific line plummeted to a shocking 72.40%. To put that into perspective, that creates a massive 19.60-point gap to their 92% target. What's even crazier is how fast this happened. It's a nearly 13.5-point drop from just the week before. Line P is suddenly acting like an anchor, dragging the entire operation downward.
So obviously we have to ask, what is this 19% drop actually costing us? Because in manufacturing, machine downtime isn't just some headache for the scheduling department, right? It is a direct, quantifiable hit to the budget. To really grasp why management went into full emergency mode, we have to follow the money.
Wow, this just completely lays it out. Line P alone accounts for nearly 80% of the entire factory's downtime costs, just that one line. We're talking almost $2,000. Because of this single erratic asset, overall week 34 downtime costs shot up 52.5% higher than the previous week, totally blowing past their proposed weekly limit of $600.
Okay, moving into section 1, the clues, unpacking the downtime data. Let's look at the specific metrics to figure out exactly why line P dropped 19%.
Our very first clue is MTTR, or mean time to repair. For week 34, this metric stretched out to 0.75 hours. Basically, this tells us that when these machines break down, mechanics are really struggling to get them back online quickly. They're missing their 0.55-hour target by a mile. It's a glaring signal of slower recovery times, which usually points to complex failures or maybe a lack of immediately available spare parts.
And then we have our second clue, MTDF, mean time between failures. Honestly, this one paints an even grimmer picture. It fell to 9.77 hours, well below their 12-hour target. So these machines aren't just taking longer to fix, they are breaking down way more often. When your time between failures drops this dramatically week over week, you're looking at a highly unstable system, which perfectly explains how you lose 19 points of efficiency so fast.
Zoom out a bit, and the sheer volume is just staggering. Look at this, 245 distinct breakdown events in August alone, resulting in 159 hours of lost production time. And remember, the vast majority of this equipment failure is concentrated right on line P. That kind of volume isn't just a fluke, that is a systemic, recurring nightmare.
All right, section 2, the prime suspects. P1, P2, and P3. It is time to narrow our focus and identify the specific bad actors causing all this chaos.
So, looking at the breakdown, 3 specific machines jump right off the page. Machine P1 is absolutely our primary culprit. It's running at a dismal 72.87% efficiency, and it's breaking down nearly every 2 hours. But it's got company. P2 and P3 are failing every 1.96 hours and 3.20 hours. Literally, all 3 of these components are suffering from extreme breakdown exposure.
And when you graph out the financial damage among these 3, the picture gets crystal clear. P1 alone drained nearly $1,000 in just the month of August. That immediately makes P1 the absolute highest leverage target for the investigation, with P3 and P2 right behind it. Bottom line, if we don't fix these 3 specific assets, line P is never going to recover.
Okay, but mechanically, what is actually going wrong inside these machines? Well, the engineering report suspects a perfect storm. Alignment faults, bad sensors, pneumatic and drive issues, all compounded by basic lubrication gaps and wear part degradation. The immediate next step here is to take these hypotheses out to the factory floor and physically validate them with focused condition checks.
Which brings us perfectly to Section 3, the Action Plan, Emergency Triage and Recovery. Let's look at what they actually did to stop the bleeding.
So here's their roadmap to recovery, and I'll tell you, it starts super aggressively. Within the first 24 hours, the mandate is pure containment. Inspect active defects, confirm temporary repairs, and get those critical spares for Line P immediately. Over the next 7 days, they pivot to focused condition checks on those exact failure modes we just covered. Then, within 30 days, they launch a formal root cause analysis. And finally, by day 60, they completely overhaul their preventive maintenance strategy based on everything they've uncovered.
But, fixes don't matter if they don't stick, right? So they're implementing strict daily governance. First up, a mandatory 10 a.m. loss review of all breakdowns from the previous shift. Next, if a breakdown lasts over 30 minutes, or if there's a repeat failure within 7 days, it instantly triggers a same-day problem-solving record. Finally, they're enforcing strict shift handover confirmations, which forces operators to take real ownership of the machine's condition every single time the shift changes.
I absolutely love this quote from the executive assessment because it pulls no punches. Quote, "Line P is the decisive risk. Immediate containment must precede longer-term improvement work. There is no ambiguity there. You simply cannot engineer elegant long-term solutions when your machines are behaving this erratically. You have to grab a bucket and put out the fire first." So the big question hanging in the air for leadership is this: will this immediate triage plan actually be executed fast enough to protect the overall factory targets? Or are these bad actors, P1, P2, and P3, going to continue to drag the whole operation down, slowly eating away at the hard-won efficiency gains of the rest of the factory? It's a high-stakes race against the clock, but as we've seen, the data tells them exactly where to start. Thanks for joining me on this explainer. I hope this deep dive into industrial problem solving gives you a fresh perspective on how hard data can drive real-world recovery.